you get to build something, and often the projects that we're engaged with, you get to build something that's going to make a difference.
People want more stuff automated, they want richer interfaces, they want bot interfaces. The architecture keeps expanding, the knowledge of Azure keeps growing. Like, I'm still learning, I'm still trying to get better, I'm still trying to make solutions quicker, more maintainable, cheaper, and you know, there's a long way to go.
I get a go-kart. So this is my red shell.
I'm talking everyone.
Yeah, money.
Go free! Go Tom! I feel like Adam's like true competitive personality only comes out on retreats. Like we go on a bushwalk, or we play tennis, or we go swimming, or we go go-karting, and all of a sudden he's just like, get out of the way!
Thank you very much for coming in, guys. I hope you all enjoyed your rides today, and I hope we see you all again, guys.
To SSW.
Bye.
G'day team, Adam Kogan here from SSW TV, and today we are in SSW Brisbane with the beautiful Story Bridge behind us, and we are in person for the first time for many years in Brisbane, so that is awesome. It's good to see many of our colleagues from around the town here, so that's awesome. And tonight we have a great night. We'll be having Luke Parker, who is by my side. He'll be talking about prototype in production. He's been working on a very large project and he's going to be telling you the war stories of that one, but basically how to deal with a lot of stuff that looks like prototype code and where the business thinks it's done and how to keep moving forward or to rewrite. So he'll talk about a whole lot of patterns that he's established dealing with tech debt. So that should be very good, but let's jump into the SSW tech news. And the first and most important news is that GitHub Copilot is available for Visual Studio 2022. Who already has installed this? Okay, so we got about half of you. All right, so that's some homework for you to all go ahead and do. If you've got VS Code, you should have it installed. And if you've got Visual Studio now, you should also have it installed. It is a better alternative than IntelliSense. It basically writes the code for you and then you don't really have to do anything else. Okay, I'm glad that some Brisbane people believe me on that one. But if you look down here closely, you'll see that you've got GitHub Copilot or you have IntelliSense next to it. So you can decide what you want, but there's no reason not to put it on. Try it out. IntelliCode, thank you for correcting me, JK. I never get away with anything. And there's no reason not to install it because if you don't like it, if you don't like all the help you're getting, turn it off. But you should try it out. I would say almost all the devs at SSW are running it, so it seems to be more helpful than not. Here's the next bit of news with VS Code. We have local history. Now, I don't know if you remember, many years ago, there was an extension in Visual Studio that did something similar to this. Let's watch a little animated GIF. We'll make a couple of changes. Watch my mouse, and we'll make a couple more changes down here. And what else are we going to do? We're going to rename this to Disposable 2. And see on the left-hand side, you've got this history. It not only knows you made some changes, but it also worked out that you renamed something. And if you make a mistake and you go, bugger that, I want to undo what I just did, okay? You know, wouldn't you like to be able to do that in conversation? You know, you've just said the wrong thing. Ups, let's go back one step there. That would have saved a few arguments, especially if you're talking about curly braces and what line they should be on. All right, so let's go to the next. Do you like that? Who thinks that's cool? Okay, oh, we've almost got 100% there. Excellent. So here is the next one. The next one is about secrets. Now, here's the story. On GitHub, sometimes a developer will commit a secret, all right? And at that point, well, you can undo it, but that's not going to do much. So you basically have to recycle your secret. Now, it doesn't happen very many times. To date, it's only happened 700,000 times on GitHub. So they have a problem, and it's a very painful problem. So what they have done is they've put this preventing secret leaks. Okay, it's called Advanced Security Secret Scanning. Okay, so they're being proactive so that you don't do this. Now, what are they doing? Let's have a look at what they're doing. Is this, here we go. Let's have a look here. So let's open this up and have a look at what they're doing. So you basically push it with a secret and it goes, hello, there's an error. Now, if you want to know the workaround they're showing you, copy that URL, come in here, paste that, then say that's a false positive and allow me to push the secret. Now, of course, the average person isn't going to go ahead and do that. Most people look at that box and go, what did I do? And they're going to call over a senior dev that goes, that just tells you you're an idiot. Don't worry about the workaround. Okay. So you like that? Isn't that awesome? That's a community service that GitHub has given all of us, right? Well, if you look closely at the fine print, it's not for everyone. That GitHub are trying to work out a way to provide enough value so that you go up from team to enterprise, and you pay $200 per year per user. And if you think that's only one of a lot of features there, but that's what they're trying to do. They're trying to ram more and more features into here, especially features that enterprises can't say no to. And, that's a pretty compelling story to get there.
It's exclusive add-on if you scroll down just a little bit.
Okay, JK wants to correct me again. Who's going to...
It's exclusive add-on.
What do you mean? What do you mean exclusive add-ons?
It looks like they won't push this to Teams and other plans.
Oh, they're saying that they won't?
Well, that's what it's alluded to.
Right,
As an
okay.
exclusive add-on.
Okay, awesome. So this one, the next news is Maui. And Maui is our Xamarin replacement, okay? So this is this is probably going to be incredibly successful. Mobile apps are pretty important. Having a cross compiler, writing once, deploying to iOS and Android and Windows is a pretty important story. And they now have this release candidate, which essentially means that it's a whole lot of bug fixes, but it's a stable API. And that stable API will mean that you've got a go live license and you're good to go. So as soon as we heard about this, we started talking about moving our Xamarin apps already to Maui. And I think if you've got a little bit of runway on your project, this is a good decision to investigate. And there is something coming, I believe, which will help you in that migration story. But if you're early on in a project, I would be seriously considering going with it. Now we've got a release candidate. Okay, next story, I want to talk about NPM. Now, do you remember recently Arnold Schwarzenegger did a video about, well, directly to the Russian people about the Ukrainian war? And he did this thing, and he's quite clever, that he was talking directly to them, and he had a whole lot of Russian subtitles. Well, that's what a celebrity can do, but what can a poor dev that is running a popular NPM project do? Well, we've covered in the last several months on the SSW Tech News some rogue developers doing some funny things. What was the last one that was done? I don't know if they reference it here, but it has happened before. Here we go. So yeah, we talked about the faker libraries where somebody got pissed off that the big enterprises weren't paying. And so he ruined his project and annoyed a lot of people. There was the left pad debacle. But now this is not like that. It's more like a protest. So this project, Event Source Polyfill, is just a little project that helps backward compatibility with old browsers. So most developers have been throwing this in forever. And when Russian developers ran this, it detected they were in Russian, and it put up a message in Russian to them. Okay, so that was the and there's been a number of open source projects that did such I guess you'd call it a peaceful protest to Russian developers. Okay, next one. All right, let's talk about this. Improved eye contact, framing, and background blur. Now, when I record a bunch of videos, and one of the things that the TV guys are always saying is stop looking at the screen, look where the camera is. Or sometimes I've used the iPad and the camera is on the side when you turn it to the side. They say, look there, not at what you're doing. It's kind of hard to do. Now, also, when you're on a real call, and it's a really important call, it's quite important to be looking at the person, not looking semi away. And that is that feature, eye contact. I guess if you're also working in a cafe or you're working, you got a dog in the background, you just want a directional mic, that story. And then there's the background blur. Now, we already have blur, but if you look at the blur, it's very clear and it's glitchy on the sides and it's pretty ordinary. If you want a super professional one, this is what is coming, but it's only for Windows 11 and it's tapping into the power of ARM chips. Now, I'm not sure how this works, but that's the story. You're getting those features with that setup. It seems to me that it must come down to the others, and this might be early. I don't. Does anyone know why they would say that was the requirements? But anyway, that's that article. All right. So next piece of news. All right, now we have Azure virtual machines with these ultra ARM-based processors. Now, what you want is a faster machine on your VM, the faster CPU that does more instructions quicker, but that costs a lot of money. So what they're saying now is that they can give you, look at this, twice the performance for the same price, essentially. They've kind of said it in a funny way, 50% better performance. Price 50% better price performance, which is double the performance, okay, for the same price. So that's the story. This is a similar story to how we were all deploying to Windows servers, and then we started deploying to Linux because it was close enough to performance and it was a lot cheaper. So here's the same story happening again. All right, let's talk about search. Search is so important. It was kind of funny on SSW TV. Ulysses released just a simple video about searching Outlook. He has 1 million emails in his inbox, and I thought, oh, nobody cares about that. Well, it was incredibly popular. Now, here's the story with GitHub. We want to find stuff, and this is the new approach. And let's have a look at what we have here. It's a couple minutes, so let me play it.
That's why we created this scope drop.
Now that scope drop down, is that new? No, it's been there for a while, so let's keep looking. At the bottom there, you can see custom scopes. So we're going to drill into that because that's the new stuff. All right. I don't have any other.
I think what we need to do is once.
No, there's no more. There's no more anyway, so don't worry. So sorry if I didn't share the screen audio. So that's the code search. I hope you like it. It looked pretty good. It's a lot more advanced than what we're used to. Now let's talk about a new feature that has come into GitHub. That is discussions. So we've got this problem. People will on GitHub have discussions in issues, and then they've made wikis, which will take away some of that stuff, but then they've added discussions. Now, discussions are on projects, but what they've added now onto organizations. So you just come into the settings and then you add it. Now, I'll just to clarify, I'll restate that. So here is a project. This is an organization, and these are the projects here, and they're the repos and the projects. This is for Scrum projects being run there, but you can now have another one here called discussions. All right, and that is where the discussions have just come. It's been added only 5 hours ago. It's a brand new nice feature. Now, for this to work, you have to have a repo called discussions. All right, or whatever you want to call it, but you have to make that. So, and this is what we have now, and you've got issues and the wiki, but you can also add discussions on a normal project, which we haven't here. All right. So great. Let's also talk about the 1st of the 1st of April. Anyone get tricked at all by an April Fool's joke? Oh, Sammy. All right. So this was released about these headphones that purify the air. Of course, everyone said, "Oh, that's a great joke," and then let's have a look. All right, so that's a pretty cool video. That ended up being a real product, believe it or not. Yes, hard to believe. Now in SSW, we do a weekly chewing the fat. It's a Microsoft form, and for the 1st of April, I didn't think anyone would really believe it, but we made a a band, and we told everyone that there's going to be a band, and you wear it all the time, and it tells you everything you're doing. And we had this one of the guys, Piers, walks into my office and goes on the day before, Adam, this is dystopian. This is disgraceful. I said, calm down, Piers. It's just for April Fool's. And then we go out to the web designer and say, hey, we need you to make a website today for launch tomorrow. And it's at the first we said it's going to track every keystroke and every tab you open and the whole thing. And then he goes, going a bit far, isn't it? And then he just does the website anyway. Doesn't. Anyway, so I did that, and you can see the responses. I got a lot of people with it, which was a lot of fun. And so I just asked them some sample questions about which band do you prefer, and what do you think about this project? Too many people thought it was okay. a bit too many. That was a bit scary. A few people got it was a joke. But anyway, so lots of funny answers there. Now, I did think. Let me just. There's one of the guys in the back of the room, Bryden, who doesn't joke around too much. And he sends this email on the 1st, all right, to the state managers and said, hey, I got a great opportunity. It's a $25 million project, but it's going to need an MVC website and support IE7. And so just testing them out, whether they would really go for such a project and make us all shocked. And so he says, oh, wow, what a great opportunity. Can I take this one? We had an older dev, Barry. He's looking for a job, but his tech stack was a bit aged. So we don't think we'd be able to put him on any work. So we let him go. But I've just caught him. We've locked him in. So I also wanted to make sure IE7 wasn't completely dead. So I asked Adam to get in contact with the other RDs, and they've already started a huge debate about it. Apparently, it's still going to be good for another 18 months, and they think this is a nice niche scenario. It's worth pursuing this opportunity so long as we have an upgrade to Edge later. So Brian gets a bit of a shock that this has gone on to the RDs, and then I reply, yeah, I've set up a call with the RDs at 12 noon. Who can join? They want to know more details. Need a technical one, John, an account manager, etc. We want to share the love around. Well, poor Bryden now was trolled, and now the troll was trolled. And so you should call Bryden. Jesus, it's quite the disaster. we had, he won't try another one anyway. Don't try trolling the state managers. Anyway, it's a lot of fun. So you might have noticed that when you came in today, we are now tapping to enter the front doors. So we were having fingerprints before. We were using these Invixium devices, and they're pretty good, but they're not always good. And especially some tradesmen that don't have fingerprints, and it was trouble. So anyway, we got rid of that. We now say that's a bad example, and now we're just tapping on with NFC in our phone. It was very painless. It's very cheap. In fact, I have the box right here. So if you want to know more, let's come up and chat at the end. It's super easy to install. It's just from Ubiquity. Great little device. Didn't expect it to work so well. So there you go. Now, let's finish with a little bit of fun from Reddit. They basically, Reddit is a community, a huge community of different people. Trying to get them to agree on a single conversation is pretty impossible. They did this canvas. So every user gets a pixel, a tiny pixel. And let's have a look at this. I'll play it so you can see. Can you imagine what would happen if everybody gets a little color? What can you do? Well, you can, I don't know how they coordinate with each other to do this. Like they create a flag, they do something else, somebody overwrites it. Like it is very, very amazing that millions of random people can somehow communicate and coordinate to build these little pictures and drawings, and some are quite clever. It's just insane. You know, you basically get a dot. It's phenomenal, isn't it? And this goes on, and this is just a time lapse of what was going on. Yeah, amazing. So Turkey's got their flag there. And somebody, oh, the UK, is that the UK flag? Looks like it. But they're having, whoa, the Americans coming through with their flag. And some pretty little things down here. Yeah, amazing. Amazing. Anyway, all right. So that's that. This and all the other talks go on SSW TV. There's heaps of good content down there, lots of things about rules and user groups and chewing the fat reviews and .NET and Scrum and lots of other stuff. So hopefully that was useful to you. If you have any comments or any news we missed, throw it down there in the comments, and I will see you in the next one. And I'll be handing over to Luke.
Thank you, Adam. All right. Hello, everyone. I'm really excited to be talking here, and it's great to do one finally in person. The last one I did was a very, very different feel when it's just staring into an empty camera, but it's great to see some faces and, well, at least the ones that I can see above the monitor. Talk is called Prototype in Production, and it's a talk that I built, like Adam said, from a large project that started off as a prototype. And then we quickly just moved on way too quickly. So how did we fix this? Lots of practices we tried and tested, and what worked and what didn't. We figured out the best way to slowly move away from a prototype that really shouldn't be there into something good. So we're moving from tech debt to a verifiably stable application. So that term is something I've coined, which we'll talk about a little bit further on. So what we're going to do is we're going to start with talking about what is tech debt, since there's some misconceptions and it's a very specific thing. Then, how do we actually identify it in our code? You can see a large code base, but how do you say this bit's tech debt, this bit is fine? Well, let's talk about that. Finally, we'll talk about how we can measure it and prioritize it, because saying this is tech debt is not good enough. You need to be able to say, well, this is really bad, let's do this first. Then finally, let's get some steps to actually get to that verifiably stable application, which is the very nice part. I've got a little star there just to denote it. Then we'll go through a demo. So I'll actually refactor some code while we're adding a feature live to a bit of a code base. And then we'll talk about how we can work with it in the Agile train and giving your product owner some business value. So a little bit about me. I love .NET and Blazor. So my recent client, I heard that it was a government client, so I was scared. I was like, are we going to be working on COBOL? But somehow we convinced them to be on the latest tech, .NET 6 and Blazor, so really happy about that. There's all my socials on the screen there if you want to look at it afterwards. So before we get into it, there's the SSW Rewards app, which you can scan a QR code at the end of this talk to earn some points. And with the points, you can get nice rewards like a screen that shows you the temperature on your cup or a nice smartwatch. So definitely watch out for the QR code at the end. So tech debt, I like to say, like if you watch the social media promo, is like this very old show. It's as if your business and your product is this train, and you, the developer, have to quickly build the train track as the train's going. So I know many of you have seen this pain. Late Friday nights, you might have accidentally deployed some bad code and you're rushing to fix that bit. So that's never what we want, and hopefully we can get away from it. So let's start off. What is tech debt? To start, we'll talk about what bugs are. So bugs are code that doesn't behave the way you expect. That's normal, right? We see something that doesn't work, that's a bug. Tech debt, on the other hand, is code that works. It works. So this is why the business often won't prioritize it, because it does work. But our expectations of what working is wrong. So this statement probably won't make sense right now, but we're going to talk about it throughout the talk. And hopefully, when we revisit it, it'll make sense. So this talk also builds off this SSW rules to tech debt. So if you want to read more about tech debt and how you can measure it, we've got some great articles there. So starting off with an analogy that some of you guys might find interesting, we've got this little comic here. So on the far right, we've got our business, and then here's our very happy looking developer stood in front of this incredibly stable, well-built house. I mean, we can sell this to anyone. So the behavior, it works. So it's not a bug, it is a house. You can see my little red friend here. He is living in the house. We can call it living. The expectation of the business is we just add the window and profit. It's all good. It's simple as that, right? It's quick job. Sneak it in, $450, the client asks you there, you can get it done. The reality is, well, we've got to find the right spot and communicate with some other team and wait for them to get back to us. And then we actually have to punch out each brick in the building by hand because the business said it has to be able to be modified by anyone at any time. So you can't use a tool. This is a very relatable thing I think a lot of developers have, where you're stuck in with a certain tech or, third-party tool. Then you have to do, this other steps, and quickly spirals out of control. So this quick step of just adding the window, we know the reality because of a lot of issues in how quickly we've got it to the current point. It's got a lot of tech debt. So why is it bad? So we know that it's bad decisions that have led up to a quick result, but it's got problems in the result. We expect it to be a great house, but it's not actually. Tech debt is really, really bad. And from a business point of view, developers burn out really quickly from having to go to a code base and it's, 20 years old, it's huge files, thousands of lines of copy pasted code. I mean, at least from a business perspective, you can sell it as, if we don't fix this tech debt, you're going to lose your employees, and that's really, really expensive. So we've got to tackle this. Otherwise, if we spend a few weeks here and there fixing it, that's way, way cheaper than all these developers hating the whole product and burning out and, not being productive. That too. So let's summarize. What is tech debt? I think Homer sums it up nicely here. It works. He's, looking great. The front is what the business sees, but the back is all the baggage behind the code that makes it hard to work on it later. So we've got it working quickly, but it is built poorly. So now how do we actually identify that in our code? So I'll start off before I go to that by asking a question. Is it faster to write code or read code? Just have a think about that for a second. So I'll quote someone who knows a little bit more about code than me, Uncle Bob. I've got one of his books, Clean Code, on my desk over there. So he said, indeed, the ratio of time spent reading versus writing code is well over 10-1. So we're always reading code. So you can bang out a lot of code easily, but maybe you come back to it in a week, a month, 3 months, and it's going to be painful to read. So we've got to make sure that your code is easy to read. So let's keep that in mind, and let's try and read some code now. So I've got an example here. So let's read this. It's new code. We've been dumped on this project. Let's read it. So we've got some variable. It's a total of move variables, okay? And we're iterating through some list, sorted channels, okay? And if the position is the same, we go to the next item, okay? So if the position has changed, then we know it's moved. It's a lot of lines, but we can go through line by line without thinking. We can digest it. Now let's look at the same code, but with some Ide refactors. So this isn't really that bad of code, okay? But if you compare it to the previous one, it takes a second to digest. So let's go through it, right? We've got sorted channels.where, and then we've got this, 2 parameters lambda, and then we're doing this, expression, and then at the end there's a dot count. It takes a second to digest. It's not necessarily complex or bad code, but if you've got stuff that takes a second to think about all throughout your code, it's always going to be a pain when you come back and need to go through files. Any day, I'd pick, 10 more lines of code if it's simple, because, If you have to touch it and you haven't been in this code in a long time, you want to be able to read it and understand it straight away, even if it's way longer. Let's go to a bit of a different example. So this is something a little bit more common that you guys might see. So if you've got ASP.NET Core APIs, this might be something you see. So we've got our attributes here describing the Swagger. We've got a parameter, the ID to delete in this case. And then we've got some data access straight in the controller. That might be good or bad. I mean, we need a bit of context. We check, do some logic, for example, checking if it's null, and then respond with the HTTP response. And then we do a bit of transaction here, right? It's not a full transaction, it's just removing one thing, and then respond with HTTP. So is this bad code? Think about that for a second. The typical consultant answer is it depends, and that's true. If your code has 10 endpoints like this, and it's always going to have 10 endpoints, it's not worth making it abstracted. You don't need to have, 4 layers and full mediator and fluent validation and, abstract your API and all of this. If it's going to stay like that, remember the first piece of code. This is simple to read. If you're jumping into this, you can go through and you can see exactly what it's doing. But what if you know that this project is going to expand? What if you know that, in the next few sprints, you're going to be adding multiple endpoints? It's just going to always expand. At this point, it's probably bad code, right? We've got tech debt because the files are going to scale. We're going to have descriptions about the API spec, like the Swagger, and we've got logic and database access and application logic all in the one spot. It's tech debt in that case, right? Because it's scaling. Tech debt becomes an issue when your application scales. It's fine when it's small, which is why we write it in prototypes, because prototypes are small. But when it scales, that's when the pain shows. So in this case, it's tech debt if it's scaling. So we'll remember this example because we're going to look at something similar all throughout the rest of the talk. So how do we spot tech debt? As I said, there's the reading. Reading is really important. So smart code is bad code with an asterisk. If you're doing smart things like using a link with your IDE, suggesting your for each should be some huge, disgusting query, that's bad code. If you're writing smart code that does something well, simply, that's not bad code. So just keep that in mind. Is this automatic refactoring actually readable? Is this simple? Do you find yourself always having to refresh through this code? Are you working on this project a lot and you go through this file and you always have to, skim through it and read it and check the database? Then it's probably bad code. If there's long functions, big classes, busy folders, this one's a little bit less important of an indicator, but it still can sometimes help you find those problem areas. And the easy one that we'll talk about in the next column is violations of SRP. So if you don't know, that's one of the solid principles, the single responsibility principle. So it says each class or function should do one thing. So we always apply this in a varying degree. So you can do it way too hard, and like I said with the refactoring of tech debt, you can refactor it, but if your project's so small and you go to this really hard, you're not going to get value. So if we violate this, it could or could not be a tech debt issue. You've got to think about it how it scales. The next problem is architectural tech debt issues. So this one's a little bit harder to spot and takes a bit of a higher level look instead of just actual reading your code. So if there's multiple external dependencies in your class or your logic in that one spot, it's probably going to have a tech debt issue, which we can talk about the problems. Essentially, external dependencies are the thing that break most, right? Because we don't have control of it, and because we're developers, we know our code won't break, but you don't know whether this external dependency is going to break. Do we repeat logic or data access? So if you've got, again, a violation of SRP, this is, if you have, not found handling or error handling or HTTP logic all throughout your code, that's tech debt. It's going to scale. If you're copy pasting code to handle these external dependencies, you probably want to refactor this. So the easy way to ask yourself, if you're going to ask yourself one question, ask this: how easily can I replace this component? So say you've got this external dependency and you've got to handle HTTP, you've got to handle the errors, you've got to handle not found with HTTP responses. If I replace this, maybe with my own database or some other service, how much pain will I have? And if the answer is I'm going to have to change everything and it's going to be it's going to be weeks, it's going to be painful, then you need to refactor this. It's a huge tech debt issue. So we know how to identify tech debt and what to think about when we're looking at code. But how do we measure it and how do we prioritize it, especially in a Scrum scenario, right? Because in sprints, we're jam-packed. It's hard to just say, can I have a month to work on this tech debt? Well, you don't. With an asterisk. If it's a really, really huge issue that's going to require, 2 weeks of straight coding that's going to disrupt the rest of your team, then you probably need to raise a PBI and work on it solely. But if it's something you can sneak in a few hours or a day, then you need to do it as you do your current work, which I'll talk about why in a second. But first, let's look at an example backlog. So in this backlog, I've got some items for this sprint. So, in the next week or two, I'm going to make the user be able to reset their password, edit some items, export some items, and filter some items. So thinking about it as code areas, just to oversimplify it a little bit, we've got users, items, items, items. So if we do it, tackling the tech debt as we do these features, naturally, with an oversimplified pie chart, right? We're tackling tech debt in the area that we're coding on. So the product's focus in the sprint will also be the focus of the tech debt, which is a nice side effect of working as you go, because the things you work on the most, you're going to work on the tech debt the most. So the hot paths that you're working on in the code are hopefully going to slowly become not as much of a pain. So from the wise words of a coworker who's sitting back there in the room, always leave the code in a better state than when you came to it. So this quote, if you think about that all the time when you're doing your features, it's a really, really important thing. If you leave it just 1% or one line better, just slightly, if every developer follows this on your team, just barely better, over a week, a month, a year, 3 years, it's going to be a whole lot better than if you just keep copy pasting, right? Because if this file's already bad, I can just copy paste and implement it because it's not my problem, right? The file's already bad. No, it is your problem because no one's ever going to fix this. So you've got to always leave it in a slightly better state. So let's think about this. Keep that in mind in this scenario. So we're asked to add a create endpoint to this controller. So it's similar code to that example we saw. We've already got this code. Now in this example, we know this project is actually going to scale a lot. We're going to get a lot more endpoints over time. So I'd argue from the issues we talked about just before that by adding this controller endpoint just in the same way as the code here, we're actually adding tech debt. So we're not making it better than when we came to it, even though we're adding a new feature. So it's our responsibility in this PBI to refactor some of this. Maybe we'll just move the data access to a service or some other layer or a separate project, just a tiny thing. Anything little, you've got to do for the rest of the file and commit that as part of your feature. And I got one question, do I keep this as part of my estimate and track it against this PBI? And yes, because you should review it and say, well, I'm adding tech debt to add this feature, to do it properly. My expectation is to do it properly, like in that start quote. To do it properly, I need to make it better. So you've got to refactor this. So we shouldn't add it in the same style as the existing code. We've got another slightly more complex scenario. So we've noticed a bug with the data from this code. And one of the model's values needs a weird calculation because we've got some old database and we've got to just add some weird statement. It's ugly. So on the left here, we've got some weird manual database access code. It's a bit complex. So we've got some issues. There's, sync of async in the constructor, not really a good practice. We've got a semaphore lock. So we're only letting one query happen at a time. May or may not be an issue, depending on the context. Probably an issue, especially if you have more than one user. We're swallowing exceptions. We're logging it, but we're not really handling it later. We're this execute thing is going to return, and we're not going to know anything went wrong. And we've also got some raw SQL. So there's a few potential issues. Again, some of these might not be issues. Like if this is just a job that happens once every 24 hours, maybe you can get away with it, but it could be an issue. So we do have tech debt. So now we've got to think about it, right? We've got to add these few lines, maybe it's 1 or 3 lines, who knows, of a weird calculation. We're not leaving it better than when we came to it. So we've got to refactor something here. We've got to leave it better. So the immediate answer, if you're a hardcore .NET person, you'd say, let's go to EF Core. And that seems daunting, right? How do I move my whole application to EF Core in this one little feature that's got 2 hours estimated on it? Well, the way you might tackle this, right, is we just move this one query to EF Core. So this is using Dapper from memory. So we can just move this one query to EF Core. We can map only the one model, or the, if I don't think it's using any foreign keys, we just move the one model and inject it once. We only have to do a little bit of code. And now that we've got EF Core there, the next feature, if you're working on some other query, you can migrate that over to EF Core. And, over a week, if you're working on these queries that are a pain, you're already going to be on EF Core a lot. And that's a lot easier and less daunting than just saying, oh, let's move this whole 20-year-old code base to EF Core. So yeah, I talked about those questions. So now here's the bit that gives you a little bit of a checklist, right? How do we get this verifiably stable application? Well, I hope at this point our expectations of a feature in our code and a functionality has gone from this to this. So, well, it's a car and it works. The other one, I mean, it's red. It's the SSW color, right? It has to be better. So let's review our thoughts a bit here. Bugs are code that doesn't behave the way you expect. Tech debt is code that behaves exactly as you expect, but your expectations are incorrect. So if you submit a PR that adds this new feature and it makes it a bigger file, adds a bit of tech debt, makes a bad decision, your expectation of having this as done is incorrect. So we've got to adjust our expectations and consequently adapt it. That's how we fix tech debt. So we've got to adjust, in the Scrum sense, our definition of done, which we can talk about later. So before we look at how to do it in a real code scenario, let's first talk about a high-level overview of how software works. Right? At the end of the day, there's an input, some sort of process, and an output. For example, if you have a UI, you might build this in Angular. The input might be the user interacting with a button. The process might be some JavaScript, and the output might be an animation or a change of state. If this is an API, you might have the input as a JSON body. It processes, like in this example, data access, blah, blah, blah. And the output is the JSON body straight back to the client. So this input, process, output, it can be anything. Now they can be implemented in a various amount of things, right? But if we keep in mind that that middle section is a black box, right? The implementation doesn't matter. To know that this works, we can check the input and the output, right? It's the same way that the business would think about it. They don't know our code. They know that when a user clicks a button, it makes an animation. They know when they submit their form, they get a response back. As a developer, the tech debt is in that black box. So to verify that it's stable, we need to unit test our inputs and our outputs. So, like I said before, migrating a whole thing into, for example, EF Core, or migrating a whole legacy app to unit test coverage from 0% to 100% is daunting. So you can't do that straight away. So in this slide, I've coined this verifiably stable application. This is the checklist that you should follow every PBI you get, every feature. Write unit tests before you change any code. So this is when you're refactoring tech debt. So you've noticed an issue. You want to make sure you don't break anything. So especially in legacy apps, right? There's lots of points that might break. So how do we know that it doesn't break? You just have to test those inputs and outputs, and the inside that you're touching, Who cares? So you got to write those unit tests. Now, you don't necessarily have to write 10, 20, 30 tests. At the bare minimum, just test, your best case scenario and maybe one or two common exceptional circumstances like, an invalid model. Then you can refactor your code. So make any changes, make it better, experiment a bit, migrate from one tech to another, split code up. That's great. Now run unit tests again, right? The ones you just wrote, run them. Make sure they're passing again, so you've got no bugs. You can actually verify it, right? You don't want to refactor this whole thing, 20,000 lines changed, and you have no idea whether you've broken your whole app or not. You need to know this, and you need to know it in small segments. So one little bit, test it. You'll notice that's a lot of work, right? And we haven't even started our actual task, but that's fine. It'll be a pain at the start, but as you keep doing this over time, you're already going to have unit tests when you get back to features. So at the start, it's going to be a pain, but in future, you might be able to skip straight to 4, which is doing your actual PBI. So do that. And then if you've added functionality, so functionality added can be a new feature, a bug fixed, modified functionality. All of that, if you change it in any way, add a 1 unit test case for that case. So if you fixed a bug, add a unit test to make sure that that bug is fixed and that it's not reintroduced in the future. That's a common one. If you fix a bug, that's great, but someone might not know the intricacies of some system and they might introduce it by accident, common mistake, and have no way of knowing that it was broken. So you've got to get these unit tests. And now, finally, you've got to ask yourself, is the code better than when I found it? So you've got to always think this. When I finished my PBI and did this refactoring, this mild amount of refactoring, maybe 10 minutes where I just split up one function into 2, something like that, is it better? If you split up a function into something that's more digestible, then probably yeah. If the answer is no, then refactor it a little bit. You've got to go back to that first step. If you're trying to change it again, add more unit tests. If you're changing what you refactor, you don't need to do more unit tests, right? You just refactor it again. So this is a checklist that is, very clunky to get started with, but if it slowly becomes automatic over time, it's going to be really, really useful. So let's try it all out. So I'm going to go to this demo where let's first pretend like we are doing a feature. So I've got this repository here, which I'll do a basic walkthrough of this example app. So I've got this PBI, and if you follow Scrum, this should look somewhat familiar, depending on how hardcore you are about it. So we've got this user story. So I want to be able to create styles with approved fonts. So I'm adding this feature. We've already got styles, but the story is approved fonts. So the application does not use default browser styling. So there's an issue where it's not validating this. So we've got to add this feature to the existing code where we add a custom case, right? And we've got this nice acceptance criteria where, okay, here's our list of fonts we can add. So let's first look at the code and run it. So let me get it up. So in this case, we've got an API and a Blazor front end. So I'm just going to run both at once. So here's the API running here. And the code is running there. So let me show you the UI. It just opened up on the side. It's over. Okay, so it's a simple Blazor app. It's using Mud Blazor if you're interested in Blazor frameworks. It's a really great UI library that has progressed a lot. And I'll show you now. The homepage is really, really snappy. And if you're looking at making a Blazor project, I'd really recommend checking this out. It's it's really mature now. There's a lot of backers, and if we look at their homepage, they've actually got usable kind of demos of components in their library. It's really cool. Anyway, I digress. So we've got this little styles page, right? And in this demo, you can name a style and give it a heading color and font and size. You can edit these and create them, right? So in the PBI, it said when we create it, this font, currently you can write anything and it'll save. So under the hood, this one sets it as the CSS font family. So obviously, if it's random, it'll just go back to the default. So we want to fix that. So let's look at the code. So in this case, we're not doing anything to the UI now. We're just looking at the API. So let me jump back to the presenter mode. So again, I've got this similar looking code to the examples we've looked at a few times. We've got this body and Swagger description, and then we've got data access straight here. We want to add some logic. We have a bunch of endpoints, and we know this application is going to add more endpoints. So by adding this extra validation logic here, I think we're making more tech debt. So I'm not leaving it better than when I came to it. If I add some, check that it's in this list in this one file. So what can we do? There's a few options, right? There's a lot of things that we could do to abstract it and make things better. So to start, why don't I just make a new project and let's call it our application layer. So this is the email generator and I'll call it .application. So we've got this web API layer and now we've got application layer. So if you're familiar with clean architecture, there's 4 layers typically. You've got your presentation layer, which in this case might be your API, where the HTTP stuff happens, and then application logic, and then below that is your domain layer, which is your models, essentially anything that doesn't go to anywhere outside. And then you've got your infrastructure, which is persistence, data access, third-party services. So let's just add one of these layers, right? In this web API, we can just say, for now, even though we're doing data access and some validation logic, let's rip this out. Let's just cut that. And in this application, let's delete the default class. And in here, let's just make a styles service. We don't really have to make an interface now. We can add it later. We can go with it straight away. It doesn't really matter. We are splitting it out. We're making it better. Okay. And here, let's make a task that create a style. Right, and we take that style model and we'll call it style. And it's not imported, right? We made the new project. So we've got to reference the web API, not the client, because that's auto-generated. Cool. Okay, and we know we're using data access right now. So let's auto-generate the code to dependency inject the DB context. So that DB context is over here, email generator context. So email generator context, and it's private. So let's name this underscore and generate the constructor. Cool. So when we add this to our service collection, it'll be injected. So now we know we've got data access here. Let me just call this context. That's a bit long. Yep. Cool. Okay, now I can paste in that logic. So let's make it functionally the same, right? Create style, add, it's the same. We've got to go to the program with the new style of .NET. We've got it all in that one file with the top level statements. So let's add this service. And we can make this a singleton for now. And it's the styles service. Cool. So we can, let's just add a reference. Oh, actually, so we've got our models in the web API layer. So we can't really reference it from, go from the API to the application and have them both pointing to each other. So, well, we've got to refactor this. We could put this in the application, but since I want to follow clean architecture later on, I don't have a huge problem with just adding our domain layer. So let's just do that. Let's call it email generator again, and I'll call this domain layer. It's a class library again, and the models have no dependencies, right? It's the domain of this. So I'll delete the default style again, and let's just cut this models class and put it in the domain. Cool. Now the namespaces will be a bit wonky, so let's just use the IDE to adjust the namespaces in the folder, and there we go. Cool. So we're using, system.text.json again. Let's import this stuff. We're missing something, that's okay. So you can see this is compiler errors, but it can quickly get out of hand when you're making a small change, right? I just wanted to rip this out to a service, and it's just got a whole spiral of issues, which this is nice because it's compiler errors. But just think about logic errors. If you've got, vital calculations and logic, things are going to sneak in. You've got to account for the fact that it will sneak in. So, let's keep going. We can put this here in the domain. It's probably not meant to be in the domain, but hey, it's better than when I found it, so I can revisit this later. And let's import that. And I know that there's some problems here. Okay. So this is a Newtonsoft. I bet I imported system.text.json. So that's a problem there. That would lead to a lot of issues later. So let's install Newtonsoft. There we go. And if we import Newtonsoft instead, there we go. So we've ripped some stuff out. You'll find that when you're ripping stuff out, your IDE will be your best friend. Doing all of this manually is a lot of a pain. I mean, even just changing a namespace, if you've got lots of files and lots of things talking to each other, doing that manually, you'd be there for years just renaming things. It's not worth it. So we've got no errors in the domain. That's cool. Hopefully, we can import this style now, right? If we reference the domain, we've now got our web API pointing to the application, pointing to the domain. Cool, cool. Now, got an error there. Style isn't assignable to style. That's fine. And I know why that's fine, because we've got an error. So this style class doesn't exist. So it's saying this random style thing isn't the same as this real style. So let's fix this again. Control dot is the writer, and I think Visual Studio 2 hotkey. So we've imported this stuff. Right? We can get rid of this broken code. Check the using statements, get rid of the broken code. And then control dot. We import it again. Everything's good. Yeah. Import it again. And we'll do that in a second. Now we can hopefully import this once we remove the reference. So there shouldn't be anything referencing the web API from the application. Now, hopefully, the web API will be happy to reference application. And let's see whether our errors go away, except for the one we haven't implemented yet. Cool. So at this point, right, we've just ripped stuff out. We've kind of separated our concerns a bit. That's great. It'll be less of a pain in the future because those projects are already there. So at the start, right, it's really clunky, it's really annoying, it's going to take ages, but at least you're not refactoring everything, you're just setting up the groundwork. So now we've added this service. Let's just inject it again. So this is the styles service, and we can add it to the constructor. That's nice. I love the writer actions that will just automatically add it to the constructor, and you don't have to worry about writing boilerplate for no reason. Okay, and let's get this output from the style service, right? And then we'll create the style and give it a style. A lot of saying the same word. Maybe we can revisit the naming in the future. That's okay. Now I guess we want to return the output, right? Because it will set an ID if I haven't set it. So let's do that. Return the output, and again, usually the refactoring lets me set the output type, but I guess it's not doing it this time. That's okay. Just do it manually. Cool. So we've got the same thing, right? All of our stuff is in the API. It's a huge pain to rip it out. So let's move the database stuff to, do I put it in the application or just make an infrastructure project? I think it's worth making the infrastructure. I see a nod. Let's just do it. All right, another class library. So email generator, infrastructure. There we go. We can delete the class. I don't know why they include the classes by default. I mean, you can include it in a template, right? But for 99% of the usages, you're always just going to delete it and make your own. It baffles me, but anyway. So again, let's refactor these namespaces. So it's in the project. Cool. And then this one's actually a bit awkward, right? Because we've got EF core. So we've got some NuGet packages. So I think instead of adding them manually, the easiest way would be to just rip these three out and put it in here. I wouldn't recommend it too much. Now I wrap it in, yeah, an item group. Cool. So let's make an item group and paste them in. And usually when you save, it'll restore the project so we can see whether that's good. Cool. No major issues there, I don't think. And now we should be able to import this stuff. Import all of them without doing a typo. And reference this. Cool. Let's see if there's any issues now. You need to import it in this file too. Cool. I don't see any errors right now, which is good. Okay, so now, hopefully, application can reference infrastructure. Cool. We've got stuff somewhat separated without changing any logic. But again, we need to verify this. So you can write the unit tests at the start or at the end. I mean, because this is small, I'm going to write them at the end, but you probably should write it at the start. Doesn't really matter in the, simple demo. Cool. So yeah, we can actually return the style, right? It'll set it on the model, I believe. There we go. Let me just check. It's been a while since I've done EF core. Yeah, I think this is right, JK, to get the ID. Yeah. Both is right. You can do either. There you go. Cool. So now we've got this output, right? Nothing's changed. It's the exact same, right? We create the style, but it's application, core, or domain, and infrastructure. That's great. Now, we don't need to say entity here now that we give it a model, and we don't need to say entity there. Even that small change, if we got rid of that, you're reducing having to say entity each time. That's a nice little fix. If you snuck that in one feature, that's leaving it better than when you found it. Right, it's removing that replicated code. So let me just see what is not building. There's a few issues. We just got to import things. Now let me say import missing references in solution. So instead of going through each file with errors, I just want it to go through 400 symbols automatically and fix everything for me. Well, everything seems to be fixed. That would have been a pain to do manually, right? Now there's an issue with the unit tests. It doesn't remove namespaces that got removed from using statements. So that's something that could be fixed. Oh yeah, so we're mocking this controller, right? But we added this service, so we've got to update our tests. So let's do that, right? And I'm not following the super best practices in the unit test, so you might use a fixture for creating mocks, or you might mock with, mock in each test. It depends on your circumstance. For this, I think it's fine to just do it in the one file. So we've got to update this. Keep in mind, we've spent a while, all right, and we haven't even touched the PBI. But at the end of the day, if someone else looks at this code after we've touched it, they're going to think we're a solution architect, even though we're just, we're just following a checklist, right? You're just making it cleaner a little bit. So let's make a new style service. And in this case, right, we can actually, I think we should make it here, right? Because we're generating a new context for the test. So let's make a styles service in the arrange. And we can give it the context. And pass it in. Cool. So in theory, we've got no errors now. So at this point, or at the start, right, we've got to think, what are we changing? What are we refactoring? What works the same, but our expectations are different? Well, in this case, right, we refactored creating. So we've got a test for delete here, but we need to test create. So to save a bit of time, I'm just going to copy this delete and then modify it a little bit, right, to make a create unit test. So let's say create with valid model adds a DB entry, right? That makes sense. So we've got this new style, and this is arranging, right? In the acting, we want to add the model. And what are we testing? What are we actually checking? We need to know the behavior, right? So when we create something, we want to know that it should contain something in the data set that matches the ID, right? That's just a simple check to say that it has gone there. So that's at the data layer. Let's unit test also the HTTP response, the action result. So the response, where are we? We actually don't want to do this, sorry. I'm talking to the code directly here. We want to talk to the controller. And then we'll say create. There we go. And give it the model. Cool. And let's say await, and then we want the response. Right, there we go. So this is what gets passed back in the pipeline. So let's say we do want it to be a type. Well, I don't remember what type it needs to be, right? Let's see the happy path. So where are we? Create. It should return created. Cool. Let's go back. So it should be the created result, and it shouldn't be anything else. But it doesn't return one specific one, so it should just be this, right? If there's an error, we don't want to specifically be this one thing. Cool. So we're testing that one thing. Now, we're going to have to run that unit test, and I'm not sure how to do that in presentation mode. So let me just open it here. And we can run all the unit tests. So you'll notice there's this create entry we've added. And who knows, maybe this will break. I'm not certain. Now we will need to build, so I'm just going to stop it here so we're not locking the file. And stop the API. And, oh, I canceled it as it was running. There we go. All right. We've got an exception. There we go. Required property is missing. So my test is bad. I didn't give it all the properties that it needs, so I guess we need to just give it some dummy data, right? Font, we can say it's something random. This color, we can just say a random color. This, we can give it a random size. Just give it all defaults. And those, let's try running it again. All right, the creator has a success, but delete is now erroring. That's probably because we only updated the model in one, right? So probably should copy paste it. Now remember, when you're copy pasting, you're probably adding tech debt. So if this was a real scenario, I probably would make a common, style for your test starter, but let's just copy paste it for now. But keep that in mind. And come on. Developers like to see green. There we go. Happy days. So where are we in that PowerPoint? Let's just Alt-Tab back there and look at this. Right past the unit test before you change any code. We kind of did that out of order, but we still did it. We did refactor that code. We've got a bunch of layers now instead of one. We've got our concerns separated. That's great. We've added unit tests and we've ran them after we refactored and they're passing. Cool. We're up to step 4. We haven't even started our PBI. So let's do it. Let's just compare how long refactoring took versus implementing this little, validation. So for now, we've got this separate service in the application layer. I think validation is the application concern, so it's good to add it here. For now, I think it's so small we don't need to add fluent validation. Something like that, we can definitely consider it, and you should always think about your options. Don't immediately jump to what you think is right. Think about them, weigh them up. Is it right in this scenario? In this scenario, since it's a demo, I'm just going to make a little list of allowed fonts, and let's make a list. I always forget the syntax of a normal array. I think it's like this, right? Yeah. Okay, so we've got to actually check that PBI, right? I don't want to give it random fonts. There we go. And this. And one more. Cool. Great. So we've got these allowed fonts in a list. Let's first, right, in this style, right, we have to check if the font is in that list. So let's just make a variable, for example, and say is the allowed fonts, are there any where x equals the style font. Here. And I don't know whether this should be case insensitive. It's not on the PBI, so we'll just leave it as case sensitive. Okay, and then if there is not an allowed font, right, we can throw some validation exception. For now, we'll just throw an exception. And you might want to make this more valuable and maybe not throw an exception because exceptions are expensive. But again, it's a demo, so let's just throw an exception if it's invalid. Otherwise, we're good here. So back in the controller, you might want to add middleware to handle an exception that's, a validation exception, instead return a bad request. But for the demo, just to make it happen, let's just do a try catch. It's a bad practice. Don't try catch in your controller, but we're going to do it now. It's a don't do this, but we're doing it scenario. So here, let's just try it. And just in case someone's listening with sound off, let's write don't do this with lots of exclamation marks. Because this is tech debt, and I would not submit this in a real PR. Okay, and in this case, it's the right exception, it's the base exception. And then we'll return the bad request, I believe the PBI said, right? If it's not in the list, we return bad request. Cool. And we need to get that output. So let's actually just do it in here. So it'll throw before it reaches here if it's a bad request. So that's fine. So we've changed functionality, right? We've added this validation. So before our PBI is done, or our task is done, whatever you want to call it, we need a unit test of behavior. So let's go in to our tests library. And let's say, so let's hide the delete one. And let's copy this create and add the case. So we need to test two things, right? A valid font works and an invalid font doesn't. So let's say with allowed font, creates, I'm just going to say creates. And then let's copy paste and call this one with disallowed font. Returns bad request. Cool. So let's make these two functionalities. So we're creating, and this font we know isn't in the list, so let's actually make it one that's in the list, right? So I think Arial was in there, and it should create, and there should be one in there, and it should be if created. Cool. That's about the same logic as before. And I'm just thinking now, our valid model is no longer valid, so let's make it a valid model. And the disallowed font, that should be disallowed. So I think we want to say that this throws, right? So I'm forgetting the way you do that now, so I'm just going to do a try catch. Again, don't do this. I forget. That's okay. So yeah, don't do this. It's just skipping my mind how you do that. So here we want to just assert, right? True exception. This should be a validation exception or something, right? But it's an exception, so this is always going to be true. That's fine. Yeah. Actually, if we think about this in a simpler way, if this doesn't throw, we want it to be invalid. So yeah, I'm remembering, right? We say throws async. There we go. Okay. Instead of doing this, which would have been a horrible way to write it. So we want to throw just a normal exception. If it's more specific, let's have it specific. And this is async, right? So got this code, we want to create it, and our model is invalid, right? Okay, that should throw the exception, cool. And if it doesn't, it doesn't. In this case, right, our act and our assert are in the same line. So a common practice that makes your test really simple is having 3 comments, arrange, act, and assert. So let's say act and assert in the one line, just since we're doing the same thing. Cool, so we've tested the behavior. Let's see if it works. We probably have to wait this, right? There you go. Let's cancel it. So there's a lot of behavior that we've changed now, right? And if someone touches this in the future, it's going to be great to know that it does work once we've got it passing, which I see. We swallowed the exception, right? We're returning bad requests, so I wrote the wrong test. We capture this. So let me undo that test. We'll act again, and then let's say the response is this again, and it's an action result. So now let's do it again the same way as it was before. So we'll assert the response should be of type, so it should be a bad request. Cool. That's a lot simpler than my first few iterations of the code, right? That's the demo luck. Your brain just flies away. All right, let's try it this time. So the allowed font creates and the disallowed font returns that bad request. So we've tested this behavior. That's great. So now if someone jumps in and maybe they're asked to add a different validation, maybe they accidentally say this is a and or something. If it's not an allowed font and something's wrong, and it should actually be an or, something like that. Something simple that's easy to sneak in. We're going to catch it, which is great. So in comparison, actually implementing the feature, it was quick, right? It took us probably 2 minutes or less, but adding all those unit tests and all that refactoring took ages and ages. But at the start, that's what you can expect. Over time, it's going to be quick. You're probably already going to have unit test coverage. Like now, again, if I touch it, like I said, I've already got the coverage, except if I fix a bug or something, I'll write one small test and that's it. So we wrote these passing unit tests. That's great. Is the code better than when I found it? Well, in this case, right, we did all the grunt work. We separated it into clean architecture pretty well. I'd say it's great. So let's make that PR. It's all good. So we won't actually do it in the demo, right? Since it's just a demo, but you can call that PBI done as soon as it gets code review passed, all that. So let's skip through back here to the discussion. So finally, right, we've got all this from a developer standpoint, from a conceptual standpoint, how to spot it. But how do we get our business and our product owners and our scrum masters to, let us do this, right? How do we get them to say, well, tech debt is important? Well, there's a few things to think about, right? Like we said, you've got to leave it better than when you found it. But how do you make that work in Scrum? Well, let's revisit our Northwind backlog for the sprint that we looked at a bit earlier, right? It's jam-packed. How do we fit in this refactoring? I can barely do these features without refactoring in the sprint. Well, you've got to look at your definition of done, which if you're following Scrum, a lot of companies will just do a daily stand-up or a daily Scrum, and they'll call it a day. They'll say, we follow Scrum. You've got to look at it. There's a lot of things in there, and one of the things is the definition of done. So each task you get, it has to follow whatever you decide as a team is your definition of done before you can say it's done. So for example, you might say it passes code review, it meets the acceptance criteria, which if we look at the GitHub, there was acceptance criteria here, right? Happy path, bad path, it meets that. Unit test pass, functional test passing. This is a common scenario, it's all great. You need to consider as a team, maybe we should add write unit test for anything that's changed, right? New features, bug fix, modified logic. And make sure to add to it, right? Code is in a better state than when you found it. So you can say to your Scrum Master, if you guys as a team decide that this should be part of your definition of done, you can say, this feature is going to take a while. I could do a quick fix and it could be really bad, but I want to do it this way because it's going to be a pain in the future. It's going to cost you a lot of money. Devs might burn out. Let's do it this way. They'll listen to that, right? So here, if we spend lots of time refactoring, you might have to say, we're only going to do half of this sprint. We're not going to do it. You have to know that you can say bad news to your Scrum Master. You can say to the product owner, this feature you want, we can't do it yet. We've got tech debt. You have to be able to say the bad news. And over time, they're going to get used to it. They're going to trust your word. And instead of saying yes to things that you know have tech debt, over time, it's going to take longer and longer to do these small things. But if you follow that and say, this time, no, we can't fit in this feature because we need to refactor, you're always going to keep tasks to a small amount. It's always going to get shorter and shorter in terms of, having to deal with the tech debt. That's your definition of done, and know to say no to your Scrum Master. They're going to be happy. If you say, we're saving you money in the long run, they're going to be happy. Now, I'm not going to say it's easy because it's never easy. You're not going to say these, one word like, oh, I got to fix tech debt. And they're going to say, okay, it's going to be hard. You're probably going to lose some battles, but bring it up in your daily scrums all the time. If it is a recurring issue, that's a huge problem. Every daily scrum, as in your blockers, say, I'm blocked by this tech debt. It's a huge problem. I haven't been able to reach my PBI yet. It's a pain. You can say that every day, and eventually they might say, okay, let's tackle this tech debt. It seems like it's a problem, because if all of you are saying it, right, it must be probably true. So to wrap up, there's some resources here, the rules I mentioned at the start. We've got the tech debt on SSW rules. There's a blog post by Adam about tech debt, paying it back. We've got another post from Atlassian about tech debt, and a bit more of a general one, what is clean code? So like I mentioned at the start, if you've got that SSW rewards app, you can scan this QR code to get those points. So I'll just leave it up for a second if anyone's scanning it online or in person. Cool, I'll move on. So thanks for listening. I've got a survey here, so I love feedback. I always want to improve. Don't be nice to me. Like I said, with your product owner and your Scrum Master, right? Give me bad news. It's the only way to fix it. You got to give them bad news. You got to give me bad news. Okay, so definitely scan that. Tell me what's bad, what's good. And I've got JetBrains. They're nice enough to give product coupons. So if you want to get any products from JetBrains, you can get 12 months for free. There. Cool. So I'll put this PowerPoint up in this GitHub repo, as well as a link to the PowerPoint and the demo. So that email generator is a separate repo. It's a fun little side project. We write lots of repetitive emails, right? So I'm making a little project that we half started, where you can maybe generate some emails. I'll link that too. So thanks, guys. It's been great. I hope you got some value out of it. It's something you really need to fight daily with your daily scrums. So thanks again.
All right. Thanks, Luke. Awesome. Now let's take some questions. I have a few questions, but I'm happy to take some. Rowan? Two.
Well, one's a comment, the other is a question.
Okay.
You made one of your slides was that it's difficult to prioritize tech debt.
Yeah.
And I vehemently disagree with that.
Yeah.
There are mechanisms out there to do it. And if you want to pull it up, and
Yep.
this is more for putting it in the recording.
Yep.
Riot Games have a wonderful article from 2015
Yep.
on the taxonomy of tech debt, where they give every tech debt item 3 metrics. And one of them is the one that I bet none of the devs in this room have thought about, which is the contagion of a tech debt item.
Right.
So, who wants to paraphrase that?
So
Essentially, Rowan is saying that
do a scroll down, it'll show
there
you.
is a great article about how to give value to tech debt with respect to metrics and
Yep.
and
So,
story points.
yep, but it's impact, fixed cost, and then contagion.
Yeah.
So if we do nothing, how will this spread through the code base? And this comes from your seniors and your architects to say, yeah, if we do nothing, all of this ADO.NET, that's just going to go everywhere.
Right.
We're not doing that.
For sure.
Right. Okay. So the point that Rowan's making is that if you leave tech debt there, it spreads. It's like a virus. And if you have ADO code in there that you're not going to get rid of, then it will just grow and grow and grow. And you've got to kind of instill this in the product owner's mind that, well, if you can't understand this, you just got to give them a bit of FUD, a bit of fear, uncertainty, and doubt to prioritize this stuff.
For sure. Yeah. So the talk, the way it phrased it is kind of more of a heuristic approach, right? It's like you're not prioritizing it as an individual.
Yeah.
So the SSW rules that I linked at the start to tech debt, it does talk about prioritizing it and measuring it, kind of similar to that. So it is important to measure it, but just saying we're adding it to the backlog and then, it just lives there forever, that's not good enough as an individual. So it's kind of extending that, which, both are very important. You're right, for sure.
So, Rowan, this might answer a little bit. This is the way that Matt Goldman approaches this. Basically, he talks a little bit about how much this feature will cost, and then he makes it very clear that tech debt is very visible to the product owner. It's there. You're always educating. It's always on the backlog. It's got a tag as well. And sometimes there's planned tech debt and sometimes there's discovered. So as you're noticing, just make sure you put it in the code with a comment to the PBI that it was discovered, and then he talks about how to pay it back. And there's an example here of code and how to put in a GitHub issue or whatever. All right, and he even puts it on some diagrams. Yeah, so it's crystal clear everywhere. All right, anyone else got a question? All right, how about I try one? How do you feel about Link? Are you anti-Link?
Absolutely not. Link is great. So the example that was against Link was, I'd say, a weak example. Link is great in a lot of situations. Sometimes the IDE will suggest, especially in like a for each loop, it'll try and shove it all into one, and that won't be readable. Link is great. I use it all the time. It's one of the best features. It makes it really readable to combine what items you want to act on and what you do in one.
Right.
So I use it everywhere, both in EF core and just in normal in-memory lists. So no, link is awesome.
Let me give you another scenario. You turn up to a project and you need to add some features onto it, but it's running .NET Framework.
Yep.
What's the story with that?
So that's a bit of a harder one, right? If you upgrade, first of all, you can't upgrade part of it easily, right, to a different version. So that's something that's going to disrupt your team because you're going to upgrade it, that versions and the build servers and your pipelines are going to be in a pain. So that's one that you might have to actually add to your backlog and say, we need, a good week or two to move this over and make sure it works, and it is going to disrupt. So that's one that you can't prioritize. That's the asterisk, right? That's the one that you do have to say, this is we're going to do it now, and we're going to spend all of our time doing this because it's disruptive.
Right. Okay. Shouldn't the answer be to talk to the product owner about that?
For sure. Yeah.
Okay.
So that's what I mean. It's disruptive. So you've got to make that conversation and say, we probably need to do this, right? Let's see if we can make this PBI in a sprint.
Right. Okay. Can you do everything that you were doing in Visual Studio? Because you were using JetBrains as writer?
Yeah. So I know a few years ago the answer would have been no, especially without ReSharper. And it's been a while since I've used Visual Studio, but I think I've read the news, and especially the latest version, I believe pretty much all of that you can do in Visual Studio for sure.
Okay.
Yeah.
I've read all the SSW rules, and I haven't seen one that says use writer. What's going on there?
I've been slowly convincing
Right.
SSW over to writer. I've got a few writer fans as well, so
Okay.
we might be convinced of making a rule soon.
Sounds like a virus. All right. Okay. At what point should you create the PBI to fix tech debt rather than just fix it?
Right, so it kind of ties into the previous question, right? If it's disruptive and something we need to discuss with the product owner, that's when we raise it as its own PBI. If it's something we can sneak in, then you don't need to talk about it, yeah.
Yes.
Yeah.
The key to that definition is disruptive.
Yes, for sure. I've said it many times. It's important.
All right, okay. Have you ever had pushback from product owners that velocity has dropped?
Product owners sometimes are nice about velocity and sometimes they're not. They might bring it up and, indirectly or directly. But again, bad news isn't necessarily a problem, or it doesn't necessarily reflect badly on you. The answer would be yes, right? It's sometimes, but you just need to know that, yes, the velocity is bad, and try and convince them that it's bad now so that it's great in the future.
Now, my experience with teams is usually when this conversation happens, they're pointing the finger at a prior developer.
Yeah.
What happens when there was no prior developers?
No clue.
No clue. All right. Is it hard getting buy-in from teams?
What do you mean by a buy-in from teams? As in getting them all to adopt this?
A lot of teams just want to please the product owner, get the feature done, and then you're in their ear saying, that's tech debt. That's not really done. Fix all that stuff up.
Yeah. So one of the ways you can start to sneak it in your team is with code reviews. So most, quite a few teams, a lot of people will leave code reviews late. So if you're always sticking into those code reviews, you can be saying, this is adding tech debt. Just refactor this a little bit, or maybe you split this into 2 functions instead of 1, or move this to a separate layer. Just add a little bit of feedback. You can still approve it, right? Especially if you're already adding lots of tech debt. Still hit approve, but add the comment and say, maybe move this to something else. So especially if you're requesting changes, right? If you add in that as well, they're going to touch the code anyway, so they're probably going to make that change. But if you try and get into that flow, then eventually everyone's going to be fixing things as they go. Yeah, it is hard though.
Okay. All right. Well, lots of good feedback online. Thank you everyone for turning up. Is there any other questions? All right. So let's call that a wrap, and let's say goodbye to all the online people. Thank you for joining in, and we will see you in the next one. Cheers. All right. Great.